All right, welcome back to a new TouchDesigner tutorial. And in this one, we're gonna look at particles in pops, and we're gonna use the ray pop to create collisions in two different ways. So we got these two examples here. In this one, we are basically using the ray pop inside of this particle system, sort of directly influencing the normals and their behaviors. And then in this one, we have a very similar setup, but we're kind of using the output of the ray pop to set up a bit of a math combine thing here. So the fundamental idea is that we have an emitter, which is just a sphere, a lot of points floating up there, and then we're moving the particles down, and then we're creating a little like collision setup, which is just some copied spheres and noise that we're like sending into the ray to create these collisions. Yeah, without further ado, I think we can just get started and recreate this from scratch. So I'm gonna delete all of this, and we're gonna start with a point generator, and the shape should be sphere. That's fine. We just want to have 100,000 points, and I'm gonna go down with my radius to 0.6. Then I want to add a transform because I want to move it up by 3. Then I'm gonna add a particle pop. I'm just gonna give this a color like orange, and I'm gonna change the maximum particles to 1,000,000 birth rate as well. I'm gonna change this to don't reuse point IDs. I'm gonna also change my life expectancy, or not mine, but the particle's life expectancy to 5 seconds, and then life variance to 1. I'm gonna change the mass to 5 and just do some velocity damping here. So that's it for now. We're gonna come back to this later, and I'm gonna add a keyboard in to be able to reset this. So I'm just gonna use this on here. I'm gonna add a null, call that p-end. Gonna color it orange as well. Drag it back on here, target feedback loop pop. And then let's add a bit of a render network here. So I'm adding a geometry, camera, render top. For my render top, I want a resolution of 1080 by 1350 and 32-bit float. I'm gonna change my view to 24 and here to 7. And then I'm gonna just add a transform and a null. Call that BG as always. Let's make a black background. And last but not least, I'm gonna add a line material. Drag that on here, par material. Let's turn off these viewers. I'm gonna turn off the line, turn on the point, and turn off the specify point far color. I'm gonna make this white and then slightly orange. I'm gonna change my point size multiplier to 0.4 and the near alpha to 0.8, which means I also have to turn on blending. Once we've done that, I'm gonna add a little bit of a movement here. So add a transform first, and let's just move it down by minus 0.008. So if we display that in the background, now we can see that sphere is falling down and sort of like fading away down here because of the life expectancy that we've set here. Then I'm gonna add a noise, but I'm gonna just like bypass that for now. But that also looks really, really cool. If you just kind of turn that on and then let it fall down, and then you could turn it on again, and that looks really nice. Okay, so the main interesting thing we want to add here is the ray pop. So I'm gonna add that. It's gonna give us this error first. If we click on it, it says not enough inputs, because we always need a second input, right? We need something that it collides with. So the first input is always like the main thing, what it's about, like the particles right now that are moving down. And the second input is the collision geometry, so that thing with which our first input collides. And yeah, that kind of like the ray pop is gonna calculate how they collide and give us all kinds of attributes that we can then use to manipulate our movement and stuff. So let's add a sphere. And before we move on, I'm gonna go to my ray and just turn on fast build. And then I'm gonna use my sphere as the second input. And now you can already see they're colliding. So there's this little problem that we have here, that it's already somehow creating particles. I don't really understand why. Maybe somebody can explain, but we're going to look at that in a second example. For now, I want to go up with my frequency to 15. So it's like a smooth sphere. I'm going to change the radius to 0.5 on X and Y, and like to 0.42 on the Y. And I'm going to change the uniform scale down to 0.4. Then I'm going to add a copy and a point generator. It's a really nice and simple way to create copies of a sphere. We can just define how many copies we want here by number of points. Add any seed. Let's add that in here. And now we've got copies. It doesn't look perfect, but that's okay. Let's turn on these because we want to use these. So first off, I want to add a noise here actually. And I'm just going to change the seed and go down with the harmonics to 1. So just so the input spheres look a bit more interesting. And of course you could go to your point generator and do maybe like less points, right? Then it's just less collision objects, or like way more. I think in this case less is more. And we might want to change the movement of the particles here with this noise. That's going to be very subtle. So we're going to do like 0.002 on the amplitude. I'm going to go down with the exponent to 0.9. And then I'm also going to change the harmonics to 0 and period to 0.24. You're going to see this number everywhere. And on my translate, I'm going to change the ty to abs time seconds times 0.5. I'm just going to copy this and put it on the translate 4D and maybe do 0.2 or something. And I'm going to scale it down. Like right now you can see it's kind of looks just like wavy like this. So if we scale it down here on the y-axis, it looks like longer kind of chunks, or I don't know, waves or something. I think it looks nicer. And then another thing, three more things. First off, we might want to create that limit effect, like with the floor. So you can just add a limit. We can change the parameter size to 3 and then just turn all, like, so we have control over all 3 dimensions. We just add a clamp here and move it down a bit. So basically whenever they reach minus 0.14 on the y-axis, they're just going to be stopped there. So it just kind of creates that kind of watery reflection look. You know, like water going, like light going through the water surface and then being reflected on the floor. That's the kind of vibe I'm getting here. So 2 more things now. One being another noise that we add afterwards. So what we can do here, we can go to map, and we're getting the ray hit normal actually. I can use that. So if I do ray hit normal 0, and we map that to the amplitude and multiply it. Basically now the noise is gonna be wherever it hits from, like bounces off of the sphere, the noise is gonna be stronger. So like the strength of the bounce is gonna be multiplied by this amplitude. So that's a really nice way. I generally love this map function. So you can use any attribute and map it to a handful of parameters in here, and then we can now multiply this. So I can set this to a very low number, like 0.02. I don't want harmonics. I'm going to go down to the period of 0.024. And now we get these kind of like, I don't know what I should call them actually. It looks different. And I think it looks nicer. And then last but not least, like this is the end of our feedback system, or like particle system. So this is all inside of the particle system. I mean, like these are not affected by it, but they're affecting the particle system. So what we can do here is we can add first math combine, and we can do A plus B, and I'm gonna do ray hit normal, change this to 0, and I'm gonna call this color RGB, right? Right now, what we're getting here is a direct translation of the values that we're getting from the ray. So the ray hit normal, actually we don't need the ray reflect in this case. So basically like in what direction or how strongly the particles are bouncing off of the collision objects. And then we're just translating that into RGB, so in color. So why I added the A plus B is because it's a bit dark. So maybe I just do like 0.5 here, and that's gonna make it a bit brighter and just look a bit nicer. We can do some post-processing here. For example, we can add feedback with a level, set that to maybe 0.7, and then let's add a composite. Put that in here, change that to over, drag it back, and put that in here. And then we can use our keyboard in on that to reset that as well. So just to see the difference, right? Like it's just kind of like, it's more traily. You can also obviously go up with the opacity here to see that more strongly. In that case, you might want to adjust like either the size or the alpha or something, right? So it looks even more like water, I would say. But I do kind of like this, the way it is. And of course, now you could also add like, for example, an HSV adjust and just kind of adjust the colors. So this is the fundamental idea, right? We can turn off the copy. We could make the sphere bigger. This could be any collision objects, could be a 3D object, this could be anything. And then this could also be anything, right? Like right now we just have one emitter that is just like kind of making particles that fall down. But for example, we could also, let's just add a copy. Let's add a circle. Let's just do 4 divisions. Put that in here. And then do like uniform scale, maybe 4. And then instead of like them moving down, I'm just gonna make them like move to the center, right? Maybe slightly to the front. So they're kind of like moving, like you can see them better. Something like that. That looks pretty cool, actually. I'm just doing this on the fly. I didn't prepare this. But yeah, so just to give you an idea, like the emitter can be anything. And let's just go back to what it was before. And the collision object can be anything. We gotta move this up so it falls down. But it also looks cool. Actually also looks cool if it spawns at the same position as the collision object. Anyways, there's plenty of ideas here, but let's look at the second example. So I kind of just copied this one and changed a few things. We're gonna look at this in a second. You can see it looks a bit different. And also like one of the major issues that I said here is that when we're restarting, it already kind of creates the particles there. Here it doesn't do that. And we're kind of more in control of stuff. So for example, we can define like how strongly they should bounce back. So now you can see they're like really like strongly bouncing away from the collision objects and stuff like that. So this is actually an example that is in the overview file of TouchDesigner. So there's this overview file that was there for the alpha version. I'm not sure where exactly you can download it, but there's a lot of examples like it looks like this. And then there's the particles and then particles basics. And at the very bottom, it's actually this example that we're going to be looking at now, which I'm going to try to explain to you. I actually found this after I made the first example. And yeah, this is using, so what we were doing before here is that we're basically directly influencing the ray attribute n here. So like the normals, and then that changes the entire system. But what we're doing here is instead of directly using the output of our ray, we're using that inside of a math combine to actually change the particle velocity. So let's do that. The rest of the patch doesn't change much. One thing that does change on the particles is that we have an initial velocity of -0.1, and this is important because we're not using a transform anymore to send down the particles. So this is important, so they're actually just being like pushed down once, and then the rest of the system takes over in a way. And then, yeah, the noise, I'm not really changing much. Okay, so let's add a ray in here again. And I'm going to use this as my second input. Oh my god. So it's important to turn on fast build. So otherwise it's going to be very slow. I'm going to turn on all of these. I'm just going to call this like distance. And just so it's like the same as in the example, reflected ray. So you can call these whatever, right? Like you're always kind of free to do that. And we're going to use particle velocity instead. And then I'm going to add a math combine here and use this as a second input. And what I also want to do is just use all of my inputs here. So I'm going to do asterisk. So we're using both attribute inputs from like, yeah, both attributes from both inputs. All attributes from both inputs. There we go. I'm going to try to explain this to you. So first off, we use a length A and calculate the length of the particle velocity and call that mag v. So what this is doing is basically just giving us the speed of the particles. So like how fast it's moving, and we're calling that magnitude velocity. We could, I guess, just call this speed as well. So then the next step is that we want to multiply the reflected ray with that mag v, and then we want to call that reflected velocity. Reflected. There we go. What this is calculating basically is the speed times the direction of where it's bouncing to. So basically what it's saying is like, if I hit something, so like let's say a point is going down and like hitting the sphere here, the collision object, then it's like the ray is gonna give us the actual, like the ray pop is gonna give us the ray, so the direction of where it's bouncing to, and then we're just saying like bounce in the same speed you were going before. So that's what we're doing here. And then we want to reduce that quite a lot because it's going to be like the falling down and then the bouncing away being the same speed is going to be very strong. So we're going to do another 8 times b. And we want to do reflected val and just multiply that by, I'm going to go with 0.05 for now. And we're going to call that reflected damped val. So basically like the damped down version of that. You're gonna see that later on what exactly we're doing here. So now we're gonna do A smaller than B, and we're gonna use distance, right? Which is what we're getting here, point intersection distance, which is basically the distance between the point that is coming in and the collision object. So, and we're saying now if that is smaller than 0.01, give that point the attribute close. So basically it's going down, then we're gonna see that, but it's gonna hit the sphere or whatever collision object we have. And then once it is, the distance it's calculating between these is smaller than 0.1, while that is true, we're giving it the attribute close. And then we're gonna use a mix ABC. We're gonna mix the particle velocity with the reflected damped val and the close. So, and we want to send this out as particle velocity. So basically what this is doing is, if it's saying like, if close is 0, then use the particle velocity, meaning like if the particle is nowhere near the collision object, then just go down straight. And if this is 1, then use the reflected damp val, which is what we calculated here, which is basically the bouncing off direction at a certain speed that we define. I hope that makes sense. Slowly starts to make sense to me. So I'm going to use A here. And another thing I learned through this example is that we can put in 3 different, or like as many different values here as we like, I guess. And we can use this 0, -1, and 0, and then use that on the part force. So now that basically does the same as using the transform and making them like fall down. So now if I reset it, like turning off the noise for now, then you can see this is working. So now I'm going to show you a few different things. So if we go down with this to like 0.5, then you can see now the particles are moving slower down, right? This is, I think, fairly straightforward. Then we have the distance. So basically if I go up with this quite a lot, you can see it calculates the distance way further from the actual object. And then I guess the most interesting one is like the strength of the reflected velocity, so like the bouncing. So if I put this up to maybe 0.5, you can see like they're falling down and then like really strongly bouncing off. So if this was 1, then they're really like going exactly at the same speed that they're coming in, basically. And then as we're multiplying this maybe by 0.0, 0.2 or something, now like they're gonna just like kind of collide, but then kind of just slide down because it's way less speed than they had before. So that is the idea here. Okay, yeah, that is fundamentally it. We can use a noise again. It's like, yeah, I'm gonna just turn that off and let's redo it. So I'm adding a noise, and of course that is going way too strong at first. So what I want to do here is I want to use the ray hit normal we did before. So to do that, I can't actually, like, I don't actually have that in here. I've got to send it through, basically. So what I can do is just add it. I don't know if it's the best way, but you can do that. It works. You can use A and then just use ray hit normal. And just, just do A ray hit normal. And now we have that here. And now we can use this element ray hit normal. And actually ray hit normal 0. We just need one value. Now basically, like, wherever the ray hit normal is stronger, so like, yeah, it's way too strong. Also, let's change this to multiply. There we go. So let's do like a really small value, like 0.01. So wherever the ray hit normal is stronger, it's gonna multiply by this value. I'm just gonna go down with my harmonics and like have a really small period. Maybe 0.24 as always. Maybe let's make this a bit stronger. I don't know. It's just something to try, whatever works best for you, but it doesn't make as big of a difference as it did before. So again, we can just turn this off, maybe go higher with this. Looks pretty cool as well. 2 more things. One being using trails. Also, let's maybe just have like this completely round sphere. I'm gonna go down drastically with the amount of particles to maybe like 100. And then I'm gonna add my trail in here. And now you can see, like, I just changed this to particle ID, resetting the poles also with my keyboard in. So it's like connected to this. Actually, this is not enough, maybe 500 particles. And then a trail length of like 5. And then we can either still use points, or I also have draw lines turned on here. And then it looks completely different, but it's also kind of interesting, I think. And then we could go to our math combine. I'm gonna turn off all the viewers. And then we could maybe go up with the value here to maybe 0.24 as always. Now you can see that the bouncing off is like way stronger. And again, like, this is just a very simple example of one sphere sending particles basically bouncing off from another sphere, but this could be anything. So now it's on you to make this more interesting. I'm just gonna bypass this, turn off my lines, turn off my points, and do 1,000,000 again. I just have the feedback on here as well. Yeah, that looks pretty nice actually, because of the stronger reflected value here. You can also negate the ray, and it's gonna be the other way around, I guess. Yeah, so instead of like being instead of bouncing off, they're now being like kind of sucked into the geometry, which is also an interesting effect. And yeah, you can go crazy with any of this. Feel free to have fun. That's what we're here for. Yeah. One last thing, actually, colors. So you can also use the ray hit normal here on the colors. I used some, like, you can use RGB, but it doesn't look that great. So I just used RGG, or you can maybe multiply this. It's gonna look quite different than before. So actually, like, from the way it looks, I kind of prefer the first one. But then with the second one, it's kind of cool to be more in control here with the math combine. And I'm actually kind of happy I understand this now. Yeah, so I'm very curious what you come up with. Feel free to tag me when you share your experiments at Electronaut. And yeah, thank you for watching, and I will see you on the next one.